So welcome everyone. This is another exciting learning lab. This one is fantastic. If you guys are into big data, if you guys are into Apache Spark, if you're into learning R and how to use some of these big data tools, this is going to be the lab for you. It's really cool. So we're going to be doing all sorts of stuff. We're going to be doing a financial analysis. I'm going to show you a state-of-the-art app that I just built today that you guys are going to get if you join Learning Lab Pro. And we've got a ton of stuff in store for you. So I do have 3 tips today I'm going to be talking through. I'm going to be going through a 2-part lesson that is going to be 300 lines of code. And as I had mentioned, there's going to be a stock app that we get at the end. So agenda today. This is going to be Spark and R. In 2 weeks, we're going to be doing Spark with Python. I'll talk more about that here in a bit as I go through the lesson and kind of explain what Spark is, where R and Python both fit. And then I'm going to be switching gears. Once we get into the code, I'm going to give you first, it's going to be a 2-part code lesson. So the first part is going to be my 3 tips. These are actionable tips that you guys are going to be able to implement immediately for how I use Spark in R. So these are going to be 3 very valuable tips. That's going to be what we touch on first in the code. And then the second part of the code is going to be building this shiny investment app, which is this thing here that you're seeing. And that's going to show you some actual big data tools, like actually working with 5.8 million rows of data. It's a NASDAQ stock index. I'll talk more about that in a minute. So as I mentioned, it's a 2-part code tutorial today, lots of code. I'm going to try and fly through the beginning slides so we can get in the code as quickly as possible. And then at the end, for any of you that stick around, we're going to be giving away some special offers for the courses. So get ready for that. You guys are all going to get some bonuses. All right, so let's get this thing kick-started. First thing, before I jump into it real quick, if you guys do have questions, put that in the Q&A. There's a Q&A panel. So make sure you put the Q&A, select Q&A, and put your question in there. I'm going to go through those at the end once we get through the special offers. All right, so here's the game plan for today. We're going to be seeing how we can utilize Spark. We're going to be analyzing a lot of data today. This is 5.79 million rows. It's going to be 4,500 stocks that we're going to be analyzing with each of those with 10 years of daily data. So a lot of data for each stock. And that's where we're getting this $5.8 million number. That's the number of observations. We're going to use a tool called Spark to analyze that. And then what we're going to be doing in stage 2 is analyzing then in R. So we're going to do our big data wrangling in Spark, and then we're going to move the data into R so we can do our cool visuals and our analysis. And then we're going to share it in a shiny app. So that's what we're going to be going through today. This is a learning lab. So if you're not familiar with learning labs, if this is your first learning lab, welcome. For any of my my Learning Lab Pro members that are in the audience, or any of my R-Track student members, make sure you let them know in the chat, welcome, and let them know what you think of Learning Labs Pro or Learning Labs, these sessions that we're holding. And this is part of a special Spark series. So you can see this arrow here. We're going to be putting this into my Learning Labs Pro topic list. You can see this is going to be the 65th lab. So we have 64, 63. These are time series, 63, 60, 54. These are all time series labs, but we have labs on all sorts of different topics. And I'll put the link in the chat here for Learning Labs. If you guys want to check out Learning Labs Pro for any of the past topics, I just put that link in the chat. We have 65 labs. When you join, you get access to all of them. You get access to a Slack community channel, and you get access to amazing topics like these. It's 1-hour courses with hundreds of valuable bonuses. Each course typically has a bonus. Today, the bonus is, or these are what I normally give away as bonus apps. So you can see the past few lessons, we've had a customer retention app, we've had a hierarchical forecaster, a loan default scorer, a customer segmentation app, NLP token automation app. You guys get access to these if you join the program. And today, the bonus is this state-of-the-art, beautiful looking app that I just built today. It's really cool. I'm going to show you how it works here in a minute. But you guys get access to this. What it does is it analyzes 4,500 NASDAQ stocks, and it allows us to sift through all of those and get to the best stocks that you want to put your investments into. So we're going to be checking that one out today. All right, so let's get into the business problem. What we're going to be doing is talking about the financial analysis. That's going to be this part 2 of the code lesson, but that's really where we want to get to. So in finance, one of the issues that we run into is there's so much data. So you've got a lot of stocks and we have to be able to sift through them. So we're going to be today analyzing this thing called the NASDAQ. If you're not familiar with finance, the NASDAQ is an exchange that houses a lot of different stocks. Anything from Apple is listed on there to a lot of like tech related companies, even smaller companies that you've never even heard of are all listed in there. And it has about 4,500 different stocks that are listed on this exchange. And those share prices are all tracked through the exchange. So the important thing about the NASDAQ is this has been the hottest stock exchange over the past 3 years. It has just been on fire. Tech in general has been on fire. So naturally, the NASDAQ has just been going through the roof. So the problem is that it's got all of these stocks, and some of them are winners, some of them are losers, and you want to be able to sift through all of them. So we're going to see how we can use tools like Spark today to be able to analyze this problem. And you can see here the data that we're dealing with. There's 4,500 different stocks, and the total data set size is going to be 5.8 million rows. So it's going to give us the big data feel. The solution is what we built today. Let's check this thing out. It's the stock screener. Let me fire it up real quick and we can take a quick look. This is the bonus that all my Learning Labs Pro members are going to get. And let me fire this up in the browser so you guys can all see it. It takes a second to load because we have to load in 5.8 million rows of data. So that's why, but once we get it loaded in, this thing, you'll see how quick it responds. So here we go. All right. It looks like it's getting close. Come on, come on, come on. You can do it. It always goes a little bit slower too when I'm on a Zoom call. Apparently Zoom takes a lot of resources. So I found this out the hard way several times in several labs leading up to this. Okay. So here's what we got going on. This is our Shiny application. You can see over here, we've got a bunch of different stocks and we're going to be measuring them. We're going to be taking a look at the standard deviation of their returns and plotting that versus the average return per day. So what ends up happening is, and it's kind of like this rule. So standard deviation is like your volatility. It measures how volatile your stock price is. And that's often thought of as a measure of risk. And then mean of your return is how much it increases per day. So if it increases, 3% on average per day, which would be great for a stock, then you would, obviously have a high mean. So what we see from this plot is we normally have to take on more risk to get more return or more reward, right? So what you want to do though, is you want to try and minimize that. So you want to pick these stocks that are getting the highest mean compared to some of these other stocks that are getting a lower mean, given their standard deviation or given the risk tolerance. So what we're doing today is we're going to come up with an algorithm using Spark to analyze all of these 4,500 stocks. And it's going to give us the 9 stocks that are projected to be the best. And that's what these green ones are. So you can see stocks like Garmin is in here, GRMN. And if we go over here, this is where Garmin's located on the plot. You can see that it's had a pretty good couple of years, especially over the past few years. It's had an awesome return on your investment if you've invested in Garmin. So that's kind of how it works. It's got some other little filters over here. I'll explain these once we get into the code, but it's a really cool app. That's your bonus today. Okay, so that's what we're going to build. Let's now switch gears, talk really quickly about Spark. So Spark, what is it? If you've never heard of Spark, don't worry. We're going to be talking. I'm going to give you the essentials, the basics of Spark here. So what Spark is it's a unified analytics engine for large scale data processing. And this is what actually is on the Apache Spark website. So what does that mean though? Let's unpack that. So I want to talk about the large scale data processing because that's really what 99% of use cases are going to be using this for, is when data becomes pretty large, so large that your business, say, has billions of rows of data. You can use a tool like Spark to be able to distribute it into clusters or what are called different clusters. So you're going to spread these computations off across clusters that are on different servers, and you're going to be able to run calculations in parallel much faster. And what Spark does is it kind of handles all of the distribution and all of the work underneath the hood. So what it does is it runs workloads 100x faster. So 100x faster than what? The benchmark is Hadoop. This is another big data technology. And actually, I think Spark leverages Hadoop. But if you just run base Hadoop, it'll take you 110 seconds to run, logistic regression with this test that they ran, and Spark gets it done in 0.9 seconds. So it's 100x faster. So it's really fast, but how do we use it? So that's the other part of that quote is it's a unified analytics engine. And what does this mean? Well, this means that we can write applications in different technologies or different languages like Java and Scala, which Spark is actually written in Java. So Java and Scala, which is a scalable version of Java, it fits into there, but it also has interfaces in Python and R and even SQL. So SQL is, Spark has its own variant of SQL, and we'll talk a lot about that today because R has a translation engine that translates R code to SQL, and it's really cool. So a little bit more specifically, let's dive underneath the hood real quick. Basically, how it works is we're going to be using it as a data scientist. We're going to be interacting with it either through Python or R. Today, we're going to be using R. And what that's going to do is allow us to interact with a Spark session that runs on this thing called a JVM. And what that stands for is a Java virtual machine. You don't really need to know what's happening inside of this box. Just recognize that Spark uses Java. So that's going to be a requirement, is we need to have Java installed on our machine if we want to be able to use R in Spark through R. And then it's going to use this, it's going to parcel out the work to executors, and it's going to be able to run our large data processing. So the interface is right here, and that's what I'm going to be focusing on today, because that's really where you're going to spend the bulk of your time interacting with it. More about Spark. So you might hear this term called Databricks. I want to explain how Databricks ties into Spark and explain a little bit of background. So Spark actually started as a research project many years ago at UC Berkeley. And during that time period, Databricks was a key contributor. In fact, the founders of Databricks were involved in the Spark project. And what happened was, as Spark evolved, it caught on a lot of steam, and Databricks built a platform around Spark. So this is why you'll hear this Databricks term or Databricks technology mentioned a lot. So the big thing that you need to know about Databricks, many enterprises have adopted Databricks. So I would say 90% of companies that are using Spark are likely using Databricks. So it's an important technology, and we need to touch on it. I will say this, we're going to not be using Databricks today because I want to actually show you how to leverage it leverage Spark, the essentials through R. And then in 2 weeks, we're going to do a session on Python. So you guys should definitely check that out as a next level to this one. So we're going to see not only how to interact through Spark through Python, but we're also going to check out Databricks and show you some of the cool things that you can do in Databricks, not only with Python, but R with SQL, and we can kind of mix and match code languages. So that's the cool thing about Databricks, is that it takes us this idea of unification of technologies one step further, and it allows us to combine R code, Python code, and SQL code all together in one spot and use Spark as the back end. So we'll talk a lot more about that in the next couple of lessons. How do we use Spark? I already mentioned there's going to be R and Python, but we need to talk about specifically what packages are available to us in R and Python. So there's 3 different things that you're probably going to interact with. One is called Spark SQL. So Spark has its own variant of SQL. You may end up having to write some SQL code if some of the R or Python doesn't do specifically what you need it to do. Generally, you're not going to need to write SQL, but in some instances, you may need to do, like, for advanced processing. So just be aware, and I'm going to show you the SQL interface today. We're also going to talk about R, and we're specifically focusing on R today. There are 2 different packages or libraries that are out there. One is called Spark R, and this one's written by Databricks. And then another one is called sparklyr, which is written by RStudio. We're going to be focusing on sparklyr today. Every version of Databricks that's out there comes with both sparkr and sparklyr. And the nice thing about sparklyr is if you know Dplyr, it has a way to translate to Spark code. So this makes it super easy, especially if you're a student in my programs. I teach the tidyverse. If you know the tidyverse, this is going to feel right at home. And it's amazing. It's going to make you so much more productive at doing your big data operations. And then in Python, there's kind of the same type of situation too. So there's PySpark, which is written by Databricks. And then there's also this thing called Koalas. These are two different libraries. So the nice thing about Koalas, which I show the logo over here, is it's kind of like what sparklyr is for R, Koalas is for Python, which allows us to write pandas code as opposed to having to write Spark code. So PySpark, you'll see a lot of people using PySpark, but you also have this option for Koalas for a lot of your data wrangling. All right, so we should be able to understand at least a little bit at the high level. So now what we're going to be doing is we're going to be diving in to the 30-minute demo. This is a two-part demo, so I'm going to try and kind of go through. I want to focus first on the essentials, though. It's really important for us to understand the essentials. So that's part one. And then part two, we're going to be doing the big data analysis. So I'm going to ramp it up to 5.8 million rows. We're going to do some data wrangling, and then I'm going to show you how you can pull the data into that gets summarized in Spark, pull it into R, and be able to have it much more manageable. Okay. So this is the code for today, the code lesson. Let me just kind of stop my R Markdown. We don't need that running right now. And I'm going to clear out, and we're going to go here to the Spark training. Okay, so for my LL Pro members, let me just talk before I jump into this code that we're going to go through today. I want to talk about all the stuff we've got going on in here. So there's a lot of folders you'll see. Checkpoints and logs. These are things that Spark kind of handles on the back end to basically log different errors and maintain checkpoints as you're going through your different analyses. And then, so we don't really need to deal with these that much. There's going to be our process data. This is where our data, as we go through our final analysis, we're going to process that data, and we're going to save it to this folder here. Raw data, this is our input data. So this is data that I have already fetched for us. So all of the NASDAQ data, you will see that this is 154 megabytes. It's a large data set. So this is that stock data of 5.8 million rows. And I also have the NASDAQ index, which is just a listing of all the stocks. So this is only 4,500 rows. So you can see it's a lot smaller, 570 kilobytes. So 154 megabytes right here in this one, the raw data. Then there's going to be some stream input, stream output. I'm going to talk more about these here in a little bit when I get to my 3 tips. But just recognize that we're going to be creating a stream input and a stream output. And then down here are our files. This fetched NASDAQ. This is actually kind of another little nice to have. This is how I fetched all of the data for this tutorial. I'm going to give that to my bonus people, my LL Pro bonus members, because you know what, you may have to, if you want to do this analysis in the future, you may want to refresh the data, and this will give you exactly how. Second, we have the O1 Spark training. This is what we're going to be spending the bulk of our time on. And then the final file here is O2 Stock Screener app. That's this one here. This is the LL Pro, the big bonus. This is that stock analyzer app. You hit the run document. I'll explain that at the end, but basically you just click this button and it's going to run the app for you, allowing you to analyze and reconfigure your analysis. Okay, so that's the files. Let's get started. We're going to be talking about, again, we've got the 2 different parts. The first part, we're going to be doing the essentials. The second part, we're going to be working with some big-ish data, 5.8 million rows, 4,500 stocks. It's the entire NASDAQ 10-year history. There are a couple of resources that I want to put in here. So let's check this out. check your chat, everyone. Click on these links. The first link that I put in here is the sparkrstudio.com, and I'll just open that up real quickly. So this is a really important resource because after this lesson, you're going to want to learn more. And if you want to learn about sparklyr in more depth, this is a fantastic resource. It's put on by RStudio, and they have all sorts of different information about like how to connect to AWS, how to work with Apache Arrow, how to use H2O, some of the extensions, and do like some really, really kind of high-end, amazing, expert, advanced stuff. So definitely check that one out. And then I will say I actually did a little bit of copying from this book today, especially for the essentials, because you guys absolutely have to check this book out. So this book, I'm going to put it in, I just put it in the chat, open it up. It's called Mastering Spark with R. It's a free resource. Get this free resource, guys, that has all of the stuff on how to use sparklyr to do all sorts of amazing things, even well beyond what we're going to go on in this tutorial today. So I'm going to get you kickstarted with this tutorial, but when you want to really extend what we're talking about today, I recommend highly these two resources that I just put in. So check them out, save them, bookmark them, do whatever you need to do. Remember them. Okay, so part one is the Spark Essentials. Credit to the R and Spark book, Mastering Spark and R, because I got most of this information through that book. Honestly, it's really helpful. So definitely check that book out. Before we get started, some system requirements. You do need to have Java installed. So I'm using Java 11 for this training, and that's compatible with Spark version, I believe version 3 of Spark. We're going to load in some libraries here first. So I'm just going to hit Control and Enter. I'm going to load FS for the file system, Tidyverse, which has Dplyr, ggplot2, all of our core. DBI, this stands for Database Interface, DBI. So when we want to write Spark SQL, we're going to use the DBI package. And then, of course, we need the sparklyr package. That's going to be what interfaces with Spark. So next, we're going to talk about Spark installation. So the first function I want to show you is we want to check what versions of Spark are available. So when I run this, it returns all of these different versions. And these are what versions are out there in the cloud that you guys can download and install. They're not installed on your machine. That's a key difference. So to install one of these versions, you're going to run this next line of code, spark_install, and I'm going to pick 3.1. And what this is going to do is it's going to actually install that for me. Now, I'm not going to run it on this call, so I'm going to hit Control-Shift-C to leave that commented. But if you don't have Spark installed, you're going to want to run that. That'll install. It'll take a couple of minutes. Spark is like 300 megabytes. So it'll take a few minutes to download. And then what you're going to do is run Spark installed versions. And this is going to show you which versions are actually installed on your computer. So you can see I've got 4 different versions of Spark. Some of these are some older versions of Spark. You can see it's using Hadoop 2.7. These ones are using Hadoop 3.2. So we're going to use the latest version. As of this lab, it's 3.1.1. So, and then the other thing is that if you want to uninstall any of these, so they do take up a little bit of space. So if I wanted to uninstall, you can just run Spark uninstall. And if I pick one of these, it'll remove that. I'm not going to run that, but if you need to uninstall something, free up space, that's how you do it. All right, next thing we need to do. So we now have Spark installed on our machine. What we need to do is we need to connect up to Spark. So this is going to, what we're going to first do is talk about a local connection, and then I'll also talk about Databricks. So we're going to use this function called Spark Connect. If you want the help documentation, it has kind of a little bit of information about this function. The things that you'll probably be interested in. Number one, we're going to talk about this here, how to connect up. We're just going to create a local instance of Spark. And then we're going to tell it which version we want to connect up to. So we have all of these different versions. And then I have a config in here. So you're going to see this config. What we can do is we can actually specify more configuration. So you can specify things like how many cores you want to use on your machine. So I have 6 cores locally on my machine, and I'm going to use all 6 of those. I'm going to say that I only want to use 16 gigs of my RAM. So I have a 32 gigs of RAM, but I only want to use 16 for this lab. And then I only want to use a fraction of that 16 gigs, so 0.9, so 90% of that. And that'll help you make sure you don't run out of RAM if you're running locally. So I'm going to save this as my conf. It's going to save that information in here. And then what I'm going to do is I'm going to run this, and this is super cool. So once I do the Spark Connect, what it's doing, it'll take a second, but you'll see over here in my connections pane, it's going to connect up to Spark. You see how it's loading objects right now. It's right now it's connecting, and we're going to see see it confirm that it's connected for us. Takes a second. It should be finishing up right now. And right now we see no tables. That's because we don't have anything. We haven't loaded anything into our Spark clusters yet that are running locally. Okay. And then that connection object, this is the SC, the output, and you can see a little bit more information about that object. So we've now connected up. And one more thing is, if you're using Databricks, as I had mentioned before, Databricks comes with sparklyr by default. So you can actually, if you want to connect in your Databricks, they make it very easy. You just do, instead of Spark Connect local here, you're going to change this to Spark Connect, and you're going to use method equals Databricks. So that's how, if you want to replicate what you're seeing today on Databricks, that's how you would do it. And then the advantages of Databricks, if you have a cluster on AWS or something like that, you can use many, many more CPUs than my 6 cores on my MacBook Pro. Disconnecting. If you need to disconnect, you're going to run this command here, and that's going to disconnect you from your connection. We'll run that here at the end. There's also a useful web interface. So the Spark Web SC, you can see this pops up. And what this is useful for is if you have long running jobs that just aren't finishing, you can kill them in here, and you can actually see which jobs are running. So that's really cool. Okay, so that's the Spark web interface. Adding data to Spark. So this is the next section. What I'm going to do is I'm going to take this empty cars data set that just comes with R. Looks something like this. It's just, again, it's a toy data set. It's very small, not a whole lot to it. But it'll be good for us to get some of these essentials out of the way. So how you would copy that is you take your connection object and you take the data frame that you've read into R, and then you can use this as a name. So empty cars is what we're going to name it. And then we're going to save this as cars. And what this is going to do is it's going to do 2 things. So first, it's going to add empty cars to our connections here. So we now have empty cars in our Spark cluster. And then the second thing is it's going to create in our environment, this thing called cars, and that's going to be a reference to that table. So that's why I'm assigning it here. If you don't assign it here, you won't have that reference. You can always do this type of way to call that table. So let me go back here to connections and see empty cars is here. If you want to know what tables are available to you, you just do this src_tables on your connection object, and you can see empty cars, and that's the name that's right up here. So think of this cars as a replacement for empty cars. So again, how we can, once you see what tables are available, you can use this tibble function with the connection object, and then you can source that table. And if I run this, you'll see it comes back with a Spark empty cars. It has 2 question marks here for the rows, and it knows that it's 11 columns. It doesn't know how many rows it is because we haven't pulled that data into R. It's on the Spark cluster, and but we can get information about that. So this cars that is right here, you see cars. This is just a reference to, it's basically like a shorthand for calling this. So if I call cars now, you can see it returns the same exact thing as tibble sc empty cars. So it's just a pointer to that connection object. Okay. All right. So you'll see, if you want to quickly get the number of rows, if I try and run this function n row cars, you get a NA, because this is actually not a R object. It's a pointer to a table that's on our Spark cluster. So there's another function called SDF underscore n row. And if I run that, I can see now that it's 32 rows. Okay. All right. So now that you got some basics out of the way, we know how to load in some data. We know how to connect to Spark. Let's get on to my tips. I've got 3 tips. These are actionable tips, things that you can start using Spark today in your own workflows. Super valuable. So the first tip, use Spark for large scale data wrangling. And we're going to talk about Spark SQL versus Spark Dplyr using sparklyr. So the first method that you're going to start, so Spark is good for data wrangling. One way to do data wrangling is with SQL. So if you write SQL code, like select count of star as n from empty cars, and we can send it to a query and it returns 32. So this is how we could, one way to do to count the number of rows that are in empty cars. But this is kind of a lot to be able to do that. Another way is through sparklyr's count, which is actually a Dplyr function. So the benefit here is that you get the same result, but you get that with less code, and it's oftentimes easier to read. And another benefit is if you know Dplyr, you automatically know Spark, which is really cool because of sparklyr. So under the hood, here's what's happening. This count function is actually converting the arguments to Dplyr's count over to Spark SQL. So to verify this, if I run count cars and instead, if I use this function called show query, we can see this is the SQL that is generated here. So we can see select count star as n from empty cars, which is exactly what we wrote up here, except we didn't have to write SQL, which is really nice. And we can verify this because if we do this DB query and we just copy and paste this SQL code in here. So if I do copy that and just paste that right in here between quotes and run it, we get that N32. Okay. All right. So that sounds pretty cool, but let's talk about, let's take it up a notch a little bit. All right. This is, that was some beginner stuff. Let's take it to intermediate now. Right. So the advantage of the Dplyr SQL translation is that we can start to use all of these Dplyr functions and it converts everything over to SQL or Spark code. So we can run it on all of our clusters. So an example here is if we want to use summarize and across. So across is a new method or a new function that's available in Dplyr. And what this allows us to do is take our cars, which is our data frame here, looks something like this. And what we can do is summarize. So we can apply the function mean across everything, all of the different columns. So let me run this, verify that it's working. And it returns a Spark data frame and it has the mean for every single column. Now, if I wanted to write that in SQL, Spark SQL code, here's what I would have to write. I would have to write literally all of this code. So these 3 lines saved me from writing all of this. And I for one, I'm glad I did not have to write all of that for this lesson. In fact, this lesson would be like 700 lines if I had to write all of that. Okay, but it gets even better. So let's talk about grouped functions. So let's take our cars and let's start to do some Dplyr pipes to them. So we're going to start with our source or cars, which is a pointer to this empty cars data frame. And we've got this data frame. We know it's 32 rows by 11 columns, even though it's showing us question marks here. So we're going to add a column to it called transmission. And all this transmission column is going to be it's going to look in our AM. And if AM is 1, it's going to be automatic. If AM is 0, it's going to be manual. And then what we're going to do is group by. So I'm going to do a group by. And what this will do is give me a group on transmission now. Okay. And then if I want to do, again, just kind of like this basic summarize, except we're just going to do MPG through carb. We don't want to summarize the transmission column. So let's run this now. And now we have just gotten our summaries by automatic and manual. So now I have the average of each column by automatic and manual. So my groups. So what would that look like if I wanted to write that in Spark SQL? that would look something like this. So again, saving us many minutes worth of work writing out all of this stuff. Okay. So we can even do more complex things. So this is a complex structure where we return a list. So Spark has this function called percentile. It's kind of like quantile in R. And what we can do is we can provide an array, and we can say, okay, I'm going to take this MPG column, which is my cars. If I take this MPG column and I can summarize and do the percentile, and it returns this list here, a double 5. So we've got 5 different, so these are all each of the different quantiles, right? So how do we get that out of there? We can use this function called explode inside of a mutate. And let's check this out. Boom, we've got our quantiles right there. So you can start to do a lot of really cool things once you know Dplyr and Spark. And the big advantage, which we're going to see when we get to the financial analysis, is we're going to be able to do with massive data sets now. So we're, data sets get too large for your MacBook Pro. You start using Spark with Databricks or Spark with AWS, and it's a whole new game. It's a whole new ball game. I'm telling you. All right. Tip 2. So that was tip 1, data wrangling. Tip 2, modeling at scale. So Spark, another reason that people use it, and that I want you to start using it for today, is when you get these big data sets, normally what we have to do as data scientists is we have to sample it down, and then we have to, pull it into our memory, and we create a model there. And that model is going to be, suboptimal because we didn't use our big data set to model it. But what Spark does is allows us to use certain modeling algorithms on your entire big data set. So, and it's really easy. So you can make a model through sparklyr. There's this function called, we're just going to take a look at linear regression, but if you type in ML_, there's all of these different, types of analyses you can do, like association rules, binary classification. You can do clustering, correlation. We'll see correlation here in a minute. Decision trees. You can do, I think, random forest, all of the big ones. So we're going to just take a look at a basic one. I'm going to create a model using my pointer to the cars, which is going to point to my empty cars. And I'm going to model MPG as a function of horsepower. So it's this one here, this row. So when I run this, Control Enter, what it's doing is actually creating a model on my Spark cluster, and it returns the intercept in the formula. So now what I can do is I can create a temporary data set. So notice I'm not naming this, so it's not going to go into my memory. And it's just going to be a tibble of horsepower, so new horsepower. So this is what that tibble looks like. It's just a column, goes from 260 to 350. And then I'm going to convert it to a Spark data frame, and I'm going to call it more cars. So notice it's not going to change anything up here, but it's just going to be a pointer to a temporary object. And see how it's question mark. If I put a name in here, it would add it to my Spark cluster. We don't want that. And then you can run your model and just use ML_predict more cars. And now I got my predictions. Pretty nice, huh? So it's not that bad. And then you can do other things like summaries. Even you can do correlations at scale. So there's other function ML core. You can run it on your entire big data set, and it'll return all of the correlations. So really cool when your data sets get really large and you can't do a full correlation analysis, or you can't do, a full linear regression or logistic regression. Just switch over to Spark and you can start to do that sort of stuff. All right. Tip number 3, and this one's really, really cool. So I didn't really explain the streaming input and output because I didn't want to, I wanted to create a little buzz, create a little excitement about this. So now we're going to be talking about what's called dynamic data sets. So me and you, we're used to interacting with just CSV files that are just sitting on our in folders. But what Spark does is it allows us to do this thing called streaming, which is where basically you're adding new information into a folder over time, and it's going to automatically pull that data in. So it's a server, it's going to continue running and running and running, and it's going to recognize when a folder gets updated, get some new information, And it could be a new CSV file. It could be a connection to a Kafka data stream, which is Apache Kafka is a streaming technology. So Spark works really well with these. So this is my tip number 3, start using it for streaming data. So how we would do that, you can run these, this stream input, stream output. So I'm going to create a folder first called stream input. It's already created, so it's just going to create this folder here. I'm going to actually delete these files out of that. So cars 1 and cars 2. And then I'm just going to put one file in there. So this is going to be my first file. I've just added write CSV to the stream input folder. And then what I'm going to do is I'm going to start a stream. So what this is going to do is we're going to use these streams. So it has a bunch of stream functions. If I do stream underscore, you can see all the different stream functions. Like you can read Delta from a Delta lake. You can read JSON. You can read Kafka, and read Parquet. And these are just different variants of how you would read in your data. We're just going to be putting CSV files into a folder. This is probably the most basic, and half of us, or 90% of us, it's probably all we're going to ever need to do. But this is really cool. So you're going to see here, we're starting a stream. And what we're going to do is we're going to do stream, and we're just going to select a few of the columns. So I'm going to take my stream here. Let's just see what happens. There it goes. So it's kicking off the stream now. And then what I'm going to do is I'm going to run this line of code here. So if I go back into this, I'm going to do some sort of data manipulation operation, and it could be anything. It doesn't need to just be like selecting, but we could be aggregating. Generally, you're going to be doing something a lot more complex than this. But what we're going to do is we're going to take our stream. So any files that get put in there, we're going to process them, and we're going to put them in the stream output, right? So this is the stream output. I'm going to go in here. I'm just going to delete all of these. Actually, wait, no, let me just delete these two. Actually, here, I'll tell you what. Yeah, let's just, we'll roll with this. So I'm going to run this. I just want to see what happens. I don't want to mess up my demo. So now we've got the stream that's running, and let's refresh it. So it's telling me that it's created this stream, and it's waiting for the next trigger. Let me delete these. Just want to see what happens. Okay. Stream right. Okay. Let's see. Okay, I might have accidentally deleted the streaming input. But so what we're going to do is we're going to add a new file now. We're going to add a new file to the stream input folder. Let me run this one. So I've just added into my input this cars 2. And in my stream output, let's see, refresh this. Yeah, I think I might have messed it up. Here, let me try and stop this. Let's try it one more time. Spark disconnect. Here, hold on. Yeah, I think I screwed up because I already had the stream output. So let me delete this folder. Okay, so now I just have my stream input. I'm going to delete this one. Let's try this one more time. Just hang tight with me, guys. I need to connect back up. So we're going to run this, Control Enter, and we'll run this. Hopefully this works. SC, come on, baby. All right, go back down here to streaming. Again, it takes a second for this thing to load up. And then I think we need to add our data to, adding data to Spark. We'll just copy this. And then in my input directory, okay. So we're going to start here. I'm going to do my stream, read my input, and then we're going to run this to start writing to my output folder. There it goes. See, it's added this folder, this CSV file that's now been processed. And then if I add a new folder, and you see how we've got this green bar here running. So think of this like a server in the cloud, and you just put a new folder now, or you put a new CSV file, and it processes it and it adds it to this new folder. So that's pretty cool. That's my number two or my number three way to use. This is just to set up basically a data processing pipeline using streaming. Okay, so there's the stream stop function. For some reason, this isn't working. There might be some bug I've got going on. So I'm just going to use this Spark disconnect. And then what we're going to do is we're going to move on to the financial analysis. So this is the more heavy duty analysis. I'm going to load up some libraries. I've actually disconnected from Spark, and we're going to create a new connection. I'm going to read in the NASDAQ data. That's this massive data set here that is in my raw data. It's this 154 megabytes. I'm going to pull that in. And then we're also going to connect up to Spark again. And then once we connect up to Spark again, we should see this change. And what we're going to do is we're going to copy this data into our Spark cluster. Now, this will take a second, so I'm going to run it and I'll explain what's going on. But basically, this is a big data set. It takes a little bit of time to transfer it into a cluster. So that's the reason that once you connect up, there's going to be some sort of time lag between where you have your data. If it's on your local machine, moving it to some clusters, it does take a little bit of time to process that. But the advantage of Spark is once it's on that cluster, it should operate relatively quickly. So it's still transferring. It should be finishing up right around, should be in the next few seconds. And then what we're going to do is I want to verify how many rows that I've got. So I'll run this line of code. Once it's done, it should spit out how many lines or how many rows. So while that's going on, maybe what I'll do is if anyone has any questions, I can kind of answer some of them. Oh, there it goes. It looks like it's finishing up now. Okay, we'll keep moving. So once this data is loaded in, we should see our NASDAQ data. Again, it's a long data set or a large data set. Here, come on, baby. There it goes. 5.8 million rows. All right, and it's now in here. So now what we want to do is a more complex analysis, right? So what we can do is this NASDAQ data. I noticed that I have this Tibble source. It's basically like in this NASDAQ data, this is a pointer to this connection here. So what I can do is I can write it this way, or I can actually swap that out and just do my pointer right here. And that'll be the starting point. So we're going to do, you can see the string of commands here. We're going to do a group by. We're going to group by symbol. So let me just run this first one. And it should run pretty quick. Again, it is a lot of data. So you see the Spark job, this thing popping up. And I just want to show you what this data set looks like. There it goes. It's done. So question mark, we already know that it's 5.8 million rows, and it's the symbol, the date, and the adjusted. And we have many different symbols in here. So what we're going to do is we're going to group by symbol. We're then going to arrange by date to make sure it's arranged in the right order. And then what I'm going to do is I'm going to add a column called lag, and it's just going to take this adjusted and it's going to shift it down by 1. And then I'm going to ungroup, and then I'm going to create a column called returns, which is going to be the adjusted, the value of that stock, the stock price. And that's what this adjusted column is. It's the adjusted stock price. And I'm going to subtract it from the previous day. And that's going to give us a value, which is how much it has increased. So that's going to be what's called returns. And then what we can do is then summarize those returns and get the average return, the standard deviation, and the count, and that sort of thing. So these are just different operations. So these operations are going to be aggregated operations that we have to run on 4,500 stocks, with each of those having, many of them having 10 years worth of data. So this is a big operation. And actually, I think what I need to do, I probably should have divided this by adjusted, because it should be the, or no, it should be by the lag. Sorry, I want to try this. Let's just see how this goes, because we want it to be the percentage increase. So once that happens, it's going to create what's called a query. Now, it hasn't actually run anything yet, and we can show the query here. So this is what that query looks like. Again, a lot of typing that we would need to do in Spark, but Dplyr is basically translating it to SQL code for us. Now, when I go to run it, it's going to take a second to run. Again, it's got a, and we'll see a little job that pops up here. Again, you know, it's a lot of data. Unfortunately, I'm only running it on my MacBook Pro today. And if you have, you know, your Databricks clusters, but you can see it's running here. Okay, there we go. It's taking 15 seconds, 16 seconds. And if this never seems like it's going to end, you can always kill it. But there, it looks like it's done. So once it's done, and now I've actually collected the results, I brought it back. So we haven't seen this function yet. So collect brings it into R. So now I have, if I look at my NASDAQ metrics tibble, instead of it being this list of 6, which is a pointer, it's actually 3,980 observations by 5 variables. So I've condensed that 5.8 million rows. I've calculated the mean return, the standard deviation, the count, and the last date, or the most recent date, for each of these observations. And you can see that's what it's spit out here. And it's pulled that from Spark into R, which is amazing, because now we can then do our analysis. So what I would do is I would write to this here, and then I would save my processing so I can do my analysis in R rather than working off the Spark cluster. So we're going to apply some screening metrics. I'm going to screen, I want any companies that have a market cap over 1 billion. So I have another data set that I'm going to merge in here. It's this NASDAQ index, and it's going to pull in some additional information, one of them being the market cap, because because I know from investing, market capitalization is a big indicator of how stable that company is going to be. So you normally don't want to go for companies that are too small in size. So we'll do $1 billion or greater, especially with NASDAQ. You'll get into some like almost penny stocks if you don't limit this. Standard deviation. This is another filtering or a screening mechanism. We're going to do any standard deviation, which is this column. So 46 standard deviation, that's pretty high. So we aren't going to want to go with something like that, but rather we're going to want to kind of keep it so that the percentage increase is more like this one here, where it's a lower volatility. And then we're going to make sure that the last date that the stock is still active, and we're going to create this thing called a reward metric, which is a way to value our stocks. So we're going to use a method that's similar to the Sharpe ratio. Basically, it's the mean return, which is this column, divided by this column. And then we want to see, you know, the ones that are higher are better. Okay. So let me try this. I'm going to skip this one for now because I may have had an error in my code that I ran previously, but we'll see. Okay, so we've got our market cap in here, our country, IPO year. This is the second data set that we're going to pull in. Now we're going to combine that with my metrics tibble. So we're going to do an inner join. So we've got our metrics, and what I want to do is inner join. I want to pull in the company name and the market cap. So if I do that, that's what this does here. And this goes fast. Whoops, I missed the end there. This goes faster because we're just doing it right from my RAM on my machine here through Dplyr. So it pulls in that data. You can see we have 3,980 stocks that we have metrics for. Some of these stocks didn't have enough data to have metrics. So that's why it reduced from 4,500 to 3,900. And those are stocks we wouldn't have wanted to invest in anyways. So next, what we're going to do, we've got the market cap in here. So we're going to filter anything to more than 1 billion. That further reduces. We're now down to 1,200 stocks. We're then going to arrange by SD. And we want to see, what the standard deviation is. This has a huge standard deviation, so we're definitely not going to want to invest in that. Standard deviation, again, is a measure of risk. You want to lower standard deviation. So we're going to filter to anything less than 1. We're also going to filter to a count. So this is how many observations that had. So you can see some of these stocks only had 184 days worth of, so they must have recently IPO'd, which means they had an initial public offering. They've only been around for 180 days. We don't want those stocks because we don't have enough history on them to be able to make a good, test of which way they're going to go. So we're going to only take data that is more than 3 years. They have more than 3 years of observations, and also that the last date was the last date that we're analyzing for. If they don't have a last date that matches the last date that we're analyzing for, that means that the stock may no longer be available, and we wouldn't want to, we wouldn't be able to invest in it. So we're going to get rid of those two. So that's what this filtering does. Let me see here. Let's see. Okay, it's giving me one. So let me go back up here. I think when I did this division here, may have thrown things off here a little bit. So let me go back to the original analysis. Run this real quick again. Run this part here. Actually, I can just pull it in. So I can read it in right here. Read it in one more try. Let's do this filtering one more time. And there we go. So now we're down to 453 stocks. Okay. And then what we're going to do is we're going to take this mean and the standard deviation. We're going to divide them by each other, and then we're going to multiply it by a constant just to make the values on the scale of like around 0 to 100. So this is just a constant that we're going to multiply by. It's going to add a new column called reward metric. And again, this is just a variation of what's called the Sharpe ratio. So we want higher is better. So 104 would be pretty good. So this MIME is probably a pretty good stock to invest in. And then we're going to come up with some descriptions. So we're going to store this as NASDAQ metrics screened. So that's going to be this here. And now we've just taken our big data from Spark, condensed it down into much smaller data, which are just our aggregates. And then now we have information about those aggregates that we can then analyze in Dplyr. That's what we're doing. So we want to check out our screening. So what I'm going to do is I'm first going to make just a visualization of all of these stocks. And I want to visualize the mean versus the standard deviation. So that's what we're going to do here. And this produces a plot that looks something like this. And this is kind of that classic shape of where as your standard deviation increases, your stock becomes more volatile, then your mean tends to increase. So you've got a higher risk to return. And what we want to do is we want to find out, okay, which of these stocks have the best combination of risk and reward, meaning they have a higher reward versus the amount of risk that you're going to take on. So what we're going to do is we're going to take our top 9 symbols. So we're going to take our NASDAQ metrics screened, which I think I need to put underscore Tibble on the end of this. NASDAQ metrics screen Tibble. This is again our 453 stocks that we've filtered down to. And then we're going to arrange by our reward metric. So, and I put a negative sign in front of it, so it's descending. So the best stock here so far is this JYNT. It's got a very high mean versus its standard deviation. So its daily return is somewhere around 5%, yeah, something like that. So we're just going to take the top symbols, slice 1 to 9. So it's going to grab our top 9, which are just it's just the first 9 stocks. And these are the best ones that we would want to potentially analyze further for making some investment decisions. Then we're going to grab out the symbol column. So we're going to grab the best symbols here. Whoops. Control Enter. So now I have my best symbols here. That's these ones that I want to investigate further. So I'm going to take my original data, this NASDAQ Tibble. Remember, this is 5.8 million rows. And then what I'm going to do is I'm just going to filter it down real quick. So I have just the stocks that I'm interested in. So now it's 21,000, and we're going to create a plot here of each of those stocks. Okay. All right. So these are the 9 stocks that we'd want to investigate further. Remember, JYNT was the best here. So that's in one of the top 9. You can see it's got a really good, definitely looks like it's made a lot of people some money. So let's talk about some conclusions. The idea here is we just went through a pretty hefty analysis. I mean, we're looking, we learned Spark, which was the bulk of it, but you see, it's not really a whole lot of lines of code to do the financial analysis. We did the Spark, it starts right here. So 178 to like 300. So like 150 lines of code. It's really not that much, but we're able to do a big data analysis now, analyzing a lot of data. So the idea is here, though, what's the next step? Well, we'd want to kind of take another look at these filters, and we could be, who knows if standard deviation less than 1 is right, or who knows if market cap, is 1 billion, maybe $500 million would have been okay, or maybe we want to increase it more to like 2 or 5 billion or 10 billion. So that's the idea here, is we want to be able to automate this, and that's where the stock screener app comes in. This is an application. When I click run document, it's going to start running an app. And what we're going to see here is that it has selectors that we're able to start toggling and tweaking our analyses. So this is what's called Shiny. It's the Shiny dashboard app. It's got these market cap right here. We can see once it fires up, it's going to pull in our data. If I increase the filter, click the apply button, it's going to now have a $33 billion, and we can see we have very few companies now. So these are more stable companies. But if you increase the maximum standard deviation, this will allow more volatile companies to be in our analysis. So whereas increasing the market cap decreased, increasing the standard deviation is going to increase. And you can see the green ones here are the best stocks. So these are the ones over 33 billion. They do have, kind of a higher risk profile. So that's how the Shiny app works. And the idea here is if you build Shiny apps, you can help your company be able to make better decisions, or you can help yourself internally be able to make better decisions by pulling in fresh NASDAQ data, updating this when you're ready to make your investments. All right, so that's the demo. Now I want to talk quickly about how do you learn what we just did. So Sparkin is amazing technology. It's just one tool in your bag of tricks that's going to help you become a data science expert. So how do you get there? We often think of like data science being this massive topic that is going to take forever to learn. And that's true if you go by it the slow way. But, if you want to become a senior data science, there's a ton to learn, but there's not a ton to learn just to get started. So to start making steps forward, there's really not. So I've created this thing called the career growth curve. And what this means is that you can break up your career into different chunks, just like you can with what things you need to learn in order to be able to accomplish or learn the skills for those stepping stones in your career path. So what this is it shows you kind of what skills you need in order to become a business analyst, then to become a data scientist, and then eventually to become a senior data scientist. And this is based on, me talking with a lot of my students, seeing how their careers have progressed. And what I've seen is that to become a business analyst, generally, R is going to be an amazing skill for you. But you don't need to learn like all the machine learning. You don't need to learn everything. You just need to learn mainly how to prepare data and visualize it. So the data wrangling code that we saw, the Spark with Dplyr. So if you learn Dplyr, you then know Spark, you're able to do big data stuff, you're able to condense that data down, and you're able to do visualizations, the first part of the analysis. And I'm not talking about the Shiny app piece that comes later, but the first piece of it, which is prerequisite for the Shiny app, is to be able to just make an analysis that you can communicate to somebody that can help make get business insights from that. So the next step is then the modeling, the machine learning. Now, we didn't talk a whole lot about that, but the machine learning is definitely going to be a key piece once you want to become a data scientist. So you need to add in things like time series analysis, ability to forecast, churn analysis, binary classification, using different tools. So you need to understand algorithms, and that gets a little bit more to learn. But once you get those down, you can then do modeling. And again, we're not even talking about apps yet, but you can do modeling, and then you can start to automate those. And that's when you become a data scientist. You now have the skills to become a data scientist. And then to become a senior data scientist, generally what you need to learn, and this is in talking with my students, is that they expect, most of these companies want cloud technology experience, things like Databricks, things like AWS, being able to start up servers, being able to work with data that's outside of your own machine. And then also being able to automate things like with Shiny apps. So we saw how we just made a few tweaks to our analysis. That's the idea. You can then start to automate and really help your company out. And I'm telling you, that's exactly, they fall in love with you when you can do this full tool chain. So that's how your career will progress. Well, it turns out that I've created a system based on this career path. Now it's called the 5-course R-Track system. And I'm going to go through in depth, kind of where these fall. So if we look at that career growth curve again, this foundations, which is what you need to learn here, that's the 101 course. So that's this course right here. It takes about 8 weeks. Think of this. In 8 weeks, you are already qualified after taking this course to be a business analyst. Like, you literally have the skills. You will learn data cleaning, visualization. You will even learn some machine learning and business reporting. And you'll be focusing on this tool chain called Tidyverse, which we saw today how important that is, especially when you go to big data with Spark. You have sparklyr that uses Dplyr. Dplyr is part of the Tidyverse. So you learn that in this course, and you're already pretty much there with working with big data. Then if you look at the career growth curve again, how do you become a data scientist? Well, it's with these courses. There's 2 keys. There's one, you need to be able to use machine learning, and you have to have a framework to be able to accomplish these bigger projects that are going to save organizations millions of dollars. And then number 2, you need to be able to know time series. Time series, I'm telling you, is one of the biggest money savers for companies. You can save companies millions and millions and millions of dollars by just helping them improve their forecasting. Everything runs off of a forecast in a company. So in order to be able to plan better, and that saves companies a lot of money, you need to know time series. So once you have these 2, you're now able to save your company millions and millions of dollars. So here it's just business insights, but now you're talking saving companies millions of dollars. And I show you how to do that in my courses. And then the final stage is the web apps. So again, in the career growth curve, we see Shiny apps here. You learn cloud technologies. You learn how to do AWS, Docker, Git. These are all the things, Shiny, HTML, CSS, everything that you need in order to be able to build this stock analyzer application. You learn in these courses here. But don't just take my word for it. We need to talk about what proof can I offer that this system will help you? Well, the best proof is from the results that they're getting from my students. So this is Jonathan. He is one of my personal friends. He is a head of data scientist and quantum mental research at Truist Securities. He also wrote Reproducible Finance in R. So this guy is an expert R programmer. He's taken my time series course. He says, I'm only 10% through, and I already picked up a couple super useful new moves. So this is, again, an expert. Jonathan is a really good data scientist, and he's picking up new moves just from my courses. So think about it. If an expert's learning these new moves, think about what it's going to do for you in your career. The next one is Chris. So Chris, he's an interesting guy. He's been with me from the beginning, and I've seen his career progress every step of the way. So just a couple of months ago, back in August, he messaged me through my Slack channel, and he said, hey, I just want to let you know that because all of your art courses, I just landed my first data science role. So he's been doing consulting gigs. He's been doing more business analyst gigs, and he's finally got his data science role. And he says, so I asked him, hey, what led to this? What were they interested in? And he said setting up shiny dashboards in AWS was extremely helpful during his interview process. He says the people interviewing him were looking for someone with knowledge of cloud solutions, even though he hasn't finished the Python course, which is another course that I offer. He said that was also a huge boost because he's going to an R company, but there are some Python people that he's going to be supporting. So he checked off a lot of these boxes. So he just landed a new data science position. And he says it's basically because of the courses. So again, just to return to this, this is how you will grow. You need to learn these technologies. And as you learn these technologies and become very productive with the company and then start to solve some big problems and then also automate them, I mean, it's a trifecta and it really helps. So in my system, you get 8 end-to-end projects. I'm a project-based trainer. I have tried, all sorts of different courses out there. I have never learned from, I've tried boot camps, I've tried MOOCs, and they just haven't worked for me because none of them, they didn't teach the way I like to learn, which is with projects. So when I started learning, and the thing that gave me the most value and was actually integrating my skills that I was learning as I was completing projects. So that's the way I teach. When you go through my program, you'll complete 8 end-to-end projects: customer segmentation in the 101, product price and prediction in the 101, churn prediction. This is a $5 million problem that you're going to solve. H2O AutoML in the 201, demand forecasting. These are $5 million problems. And then you're going to create apps too. You're going to do a demand forecasting app, a product price recommender app, a stock analyzer app that has users. This is one that companies will pay a lot of money for because it has users. And then application library as well to house all of your apps that you're creating. So these are the things that you learn how to do. Let's talk more about results. My transformations. This is Jennifer. She landed a VP of strategic analytics role. How'd she do it? She said what she learned so far was enabled her to be able to do an in-depth analysis during her interview. She followed the business science problem framework, which is what I teach in my 201 course. And she also was able to complete her interview project, a take-home project with R Markdown. So I teach that in my 101 course. The polished finished product impressed the hiring manager so much he was willing to fast track an offer. Not bad. So she just landed a VP strategic analytics at JP Morgan Chase. But it's not just her. It's many students are having similar results. Masataki, he got a data science job first at Deloitte and then at BCG Gamma, another consulting firm. Zidu, he's now a data scientist with Amazon. Mohana, he's gotten 3 raises in a year, which equated to about a 40% raise. Herb, he was able to build his first Shiny app within 3 months. And actually, he just got promoted to a senior data scientist. And then Raj, he actually won the 2020 Shiny competition. So pretty good results here. How are they getting these results? It's again with projects. It's the same approach that worked for me. This is why I built it. So this is a stock analyzer, an example, just one of 8 projects that you complete in the courses. So summary of this, thousands, there's in this 5-course art track, there is 1,000+ videos. There is 130+ hours of content, 8 end-to-end projects. I didn't talk about this, but there's also a private community of membership, of mentorship. So I actually mentor my students virtually through the Slack channel, which I have shown here. And it helps a lot, especially when they get into sticking points, when they run into errors. So how often, have you tried a course and you ran into an error and there's no one you can get help from? This is how you do it. You get lifetime access, 30-day money back guarantee. And I can tell you this, my refund rate is so low, it's shocking because people are getting so much value out of this. So I think I have 1.5% refund rate. And that is because the other 98.5% of people are super satisfied. They're so happy with this. This is a $5,000 value, at least, just the apps alone that you learn how to build in this. Companies would pay $10,000+ just for that stock analyzer app that manages users. So it's definitely a lot of value. So I normally offer it for $19.99, but I want to give you guys a discount today. So for the next 30 minutes, I'm going to give you guys a discount, $16.99. For those of you who want to join, I just click the button and I'm going to answer some questions. But first, let me give you the link for the 5-course art track into the link so you guys can check it out. I just put the link into the chat. You can get access to it for $16.99. Let me pull it up real quick so you guys can see me click what you need to do. So you'll see that there's 15% already factored in. If you just click this enroll in course button, it'll take you down here and you'll see the price factored in right there. Just click the enroll button and that'll take you to the section where you need to go in order to get enrolled in. And you just fill out your information here and you're good to go. So with that said, that is the offer. And I'm going to handle some questions now for anyone who's put them into the Q&A. And I see a lot in the Q&A. There's 27 questions here. So I'm going to go through it. First question here. Will the recording be available for watching again? Yes, but it's going to be in Learning Labs Pro. So you need to sign up for that program. I'm going to put that link in the chat here too for anyone who wants to sign up. I keep all of my labs in there. So you'll now have, this is lab 65. So you have 65 labs. Each of them have code just like what you saw here today. And they have shiny apps, they have the bonuses and everything. So if you want the video, go there. If you want the code, go there. If you want the data, go there. If you want the app, go there. Can we get a recording of this presentation? So this is anonymous. Just like I was saying to Adbait, check out Learning Labs Pro. I just put the link into the session, into the chat. Go to the chat, click the link, check it out. All right. Christopher asks, do you have any insight regarding the sparklyr versus the Arrow package? So I actually haven't spent a whole lot of time with Arrow. So I really I honestly don't feel qualified to answer this question, unfortunately. But I think probably with a little bit of Google searching, you'd be able to find this one out. I'll hop into Google really quick. So Arrow versus Spark. When I check this out, you can see that there's some introduction, some information there. So unfortunately, I don't have the answer. I don't want to spend a whole lot of time on this one. So I would just do a little bit of strategic Googling. Rashab asks, hi, Matt, kudos. Well, I'm a beginner in R and I have no knowledge about Spark or big data, but I do have knowledge about Python and Matplotlib scikit-learn. I have an understanding of machine learning. Besides, I'm a web backend developer with skills. So he's got a good background. He's got a really good background. I also want to break through in big data technology and more. Can you please guide me? So Rashab, what I would say is definitely take a look at the 5-course R track. I'll put the link again into the chat. You can get not only do you get 15% off today, but there's mentorship through the Slack channel. I want to talk about that real quick because this is something that often gets overlooked by my students, and it's really powerful. So here's an example of how we use the Slack channel. So the first one is if we go to like the week 1 of R. So you'll see people are asking, questions that they need guidance on. So like, what's the difference between this thing's called the pipe and the plus sign? And you can see that Auntie jumps in. So Justin asks the question, Auntie gives the answer, and then I fill in some gaps there. And between both of us, within just a few seconds, Justin's getting the answers that he needs. But it's not just that one. It's any question that you have that's related to stuff in the courses. So that's the one way that I can help you is through the Slack channel. And then also you'll see too, you can learn from your peers. So one of the things is there's Ask the Professor. So I get a lot of questions through here. Like Sebastian's asking, about to start part 2 of the time series. Very excited. I want to ask you another question. Maybe you can explain. And he's asking here about, and I just answered this one today, feature engineering. So I gave him a little bit more insights. So I tell him to use the recipes package and just kind of, give him a little bit of insights. So you can ask me, or you can also ask the community. Asking the community is fantastic because then you get people that are your peers as well that are going through the same thing as you. So this would be good for like if you're running into an issue, with an interview. And it's maybe not necessarily related to the course, but it's kind of, related to your development, and other people are going through interviews right now. So you can ask that right there and you get answers. So it's really cool. I definitely check that out. That's how we can help you beyond just the courses. So the courses give you the technical skills. The community is what helps you build kind of and get mentored along the way. All right, so that was a good question. That was Rashab. Anonymous asked, do we get access to the sample code from the session? Yes, if you join Learning Labs Pro, you get all the code, you get the bonuses, you even get that tidy quant, the pulling, the fetching the NASDAQ prices, and you get that big bonus, which is the app. So you get everything that you've seen today. That's in Learning Labs Pro. Jamie asks, hi Matt, can we use tidy models while interacting with sparklyr objects? So I don't, that's a good question. I don't think that they have all of the, I think they have them separated now. I'm not sure that you can do sparklyr and tidy models together. I know some of the algorithms have a Spark option. So let's just do Spark tidy models. And I think Spark ends up being an engine for some of the models, but I don't think it's all of them. So let's see. Ranger, they've got, let's see here, bear with me a second. I want to scroll down. So they should have, so in the set engine for Ranger, I think you can do set engine Spark, I believe. So let's check out. Let me check out this rand forest function. Yeah, so it's got a Spark. It's got a Spark engine. Okay. So this one has Ranger, random forest. These would be rate and R, but then you also have the option to do Spark. If you're connected to a Spark cluster, you can use some of the tidy models for that. So good question there. All right. Eric asks, is there going to be a recorded version that I can go back and over later? Yes, in Learning Labs Pro, definitely check that out. And you can, let's do this. I'll put Learning Labs Pro back into the chat. So if you need Learning Labs Pro, just check it out. I just put that link in again, and you can get access to the recording. I will have it up. It usually takes me a day. So be patient. If you sign up today, it won't be in until tomorrow. That's because I have to do a little bit of editing, but it'll be in there right away. Okay, so we have recently moved to AWS. Anonymous asked us, how can we connect to Spark and AWS work? Currently, we are using Dplyr. So Spark and AWS, you can check this out. So Spark, AWS. So you can see running on demand serverless Apache Spark, Apache Spark on EMR. So there's a lot of stuff here, some tutorials to get you guys set up. I don't go into the setup of Spark, but I think through some of the information here, you should be able to figure out how to set up Apache Spark on AWS so you get the advantage of big data. Okay, next one, let's see. So that was this one here, anonymous. So Harlan asks, okay, is there an explode outer? I think explode removes records where there are missing values that might not be what is wanted. So I'm not 100% sure. We'll have to check out which functions are available. Check out sparklyr, and let's just see here real quick. If I go to my console, if I do explode sparklyr explode, I guess it's going to be the Dplyr. Let's see where explode is. So okay, it comes from, looks like the grid package. So yeah, I'm not 100% sure if there, if there's going to be an explode outer or not. It's a good question. Again, I think we'd have to Google that. Okay, Husem asks, I want to know the difference between parallel library and sparklyr. So parallel is just on your local compute. So if you use like do parallel, which is one of the things, like I integrate that into model time. That's great if you're on your local machine and you've got CPUs and you want to spread out your computations over all 6 of those clusters. But what Spark does is Spark allows you to leverage, clusters that are on AWS, where you can spread your computations over many different servers that you've actually created. So you could have, in theory, hundreds of different servers, each with many CPUs, and you can take advantage of all of those CPUs, like thousands of CPUs. And that is something you can't do with the parallel package. So hopefully that explains the difference. So Spark is kind of like parallel on steroids. Anonymous asks, how does Stream work with AWS S3 buckets? So that's a great question. In fact, I think there's a stream that you can set up for S3. So if I do stream underscore maybe S3, AWS, no, stream. So there's stream CSV. SQS. Yeah, I think there's ways to stream AWS S3. I honestly, so sparklyr stream AWS. Yeah. So if you go to RStudio, remember that that link that I sent to you? So you can create an AWS instance, sparklyr connect. So when you make your connection, and then you can stream, let's see, should be able to stream. Yeah, maybe this isn't the right one, but you should be able to set it up to stream using like a cluster that you set up on AWS and using S3 buckets. So here's an example here. It looks like S3 buckets, Spark Connect. So this is Spark read, but you would do stream read, and then you should be able to just do your analysis. So it should be possible to set it up with a S3 bucket, like what they have shown here. Okay. All right. So how does Stream work with machine learning, and when do you think we must use Stream? So Stream, you could do instead of your data analysis, I think you should be able to do modeling, but streaming is more for processing the data, I would say. So let's do AWS or Spark stream modeling. Yeah, I'm not sure how it would work with modeling. I haven't tried it yet, but what I see a big advantage of with the streaming is, and maybe you could make just like one model and make your predictions, and then have those predictions be applied to each of the new data sets that you would be streaming. That might be one way that you want to try and use it. I don't know if you would model new data using streams, or if you would have a model already created and then just apply that during the stream. Okay, but very good question. All right, Luis asks, are you recording the webinar? Yes, this webinar is being recorded and it will be added to Learning Labs Pro. It should be up around 9 a.m. tomorrow. All right, I'm going to put in the, for anyone else that needs the 5-course art track, I just put that in the chat. If you guys need that link. Mohit asks, how do we access the NASDAQ raw files? So in the Learning Labs Pro, I've added a fetch NASDAQ script. It uses my tidyquant package to grab all the stock prices. So you'll get that if you sign up for OL Pro. I think you need to put parentheses. That's probably what it was. I think that was the issue. So I'm going to go back through before I send this out. I'm going to adjust this. I think it needs to be adjusted minus lag divided by lag. So we'll make that fix before I send it out to Learning Labs Pro. Anonymous attendee, SDF collect is faster than a collect. That's good to know. I know that there's a bunch of SDF functions for the Spark data frame objects. So we'll have to see, if there's some performance improvements. But yeah, that's a good one to add in there. Good call on the adjusted and minus lag for the return calculation. There we go. Yeah. And then he's got a few other ones. Would you share the R script? Yes, I will share that with Learning Lab Pro members. Let's see. Okay, Kadir asks, I would like to know AI in data science, Python, R, and Shiny are useful in building smart cities. Okay, yes. I teach both R and Python. Definitely check out the R track. I just put that link into the website. We've got just a few more minutes, 15 more minutes, and the offer goes away. Anonymous asks, will you upload this video to your YouTube channel? Probably not. I don't think I'm not planning to upload this one to the YouTube channel. Gaurav asks, do you have any data engineering track? Not into data science. No, I don't. I primarily teach data science. That's my background. Down the road, we may get into data engineering, but it'll probably be quite some time because there's a lot of data science topics that we have to cover. Gaurav asks, are there any free platforms to work on big data? So if you go to Databricks, they have a community edition. That's one thing. We'll actually check that out in 2 weeks for the Python course. Gaurav asks, AWS is really expensive. I was on the hook for a $400 bill for nothing. Yeah, AWS, you really have to set up alerts. So there's in your cost management in AWS, make sure you set up alerts. It'll give you billing alerts if you pass different thresholds. I personally have been on AWS for several years. My bill each month is only around $50 or $60, and that's because, and we have a lot of stuff going on there. About how many users can a scaled Shiny app serve, like an estimate? Well, it just depends how you have it set up. Normally, with smaller apps, it's normally like 5 or 10 users, but I've seen companies that have done it with 1,000 users or more. Generally, you have to use better tools like data table for faster processing. And on top of that, you may need to use Kubernetes as well to create different apps for different users. James asks, will Spark make more sense when I finish the AWS and EC2 sections of the DS4B web app course? So James, actually Spark is fine right now. Once you have the 101 down, you actually have most of the skills that are needed to use sparklyr. The only difference is when you get into Spark, most companies are using things like Databricks. So they'll usually have Databricks set up, and the idea is that instead of running the calculations on your laptop, you'll be pulling data from like a big data source that they have, maybe billions of records. And you would do that through Databricks, or you do that like we showed here, connecting up to the Spark cluster from your machine and accessing it somewhere in the cloud or somewhere on a different server. Okay, so no, you don't need to complete the AWS and EC2 sections of the 202 course. However, that will be really powerful if you want to start making like higher end web applications that have users. And we teach that in the 202 course, because you need AWS for your cloud, setting up a cloud EC2 server. And you need to be able to put stuff on that server so others can access it, meaning like your web app, when you distribute it, you want to have it on a cloud server. So that way anyone can access it, and you can limit the access to specifically who needs it. So you learn all of that in that course. Charles asks, will H2O and Lime work with Spark? So H2O has H2O sparkling water. It's an extension for Spark. So H2O sparkling water. And this is a product that H2O offers that allows you to get the big data, utilize both H2O and Spark. It's open source, free to use, and it really, it's amazing. So this is another area where learning a little bit of Spark, learning a little bit of Dplyr, and then learning H2O, you can then combine these technologies. So I teach H2O in my 201 course. I teach Dplyr in my 101 course. With those two courses, you have enough to be able to use sparkling water. And then you can kind of basically run H2O just like you would instead of the ML linear regression. You can run H2O's more powerful modeling capabilities on big data. So great question there. That was a really good question. And then Lime is more local. So you'd pull your data down in, or you'd pull your model in and probably run Lime on just a subset of the data. Juan asks, thoughts on using AWS versus GCP versus Azure? So I do have a lot of thoughts. All of these cloud technologies are very, very similar. AWS is one that I recommend to learn because it's the most bare bones. It tends to be a little more challenging to learn, but it's great because you get to learn like through building EC2 servers and actually working with Linux and having to add software to them. Whereas like Azure and GCP, they try to take away a lot of they kind of hold your hand, but I think that hurts you a little bit because you don't get the full understanding of how to set up servers, how to manage, firewalls and those sorts of things. So I recommend learning AWS. I teach AWS. It's very bare bones. And it's something that's great to learn. Honestly, it'll help you a lot. It's a great resume builder. And also it's just great because it helps you with your knowledge. And switching from from AWS to Azure, virtual machines, or GCP also has their cloud compute. It's the same thing as EC2. So once you learn EC2, you already know Azure. You already know enough, to be dangerous with GCP. It's just, I think AWS is the right one because it's more bare bones. It's up to your own personal preference. But once you learn one cloud, you know them all. There's transition. They all have like different technologies. They have different names, but they're the same thing. Okay, James asks, is Spark used on or in AWS for access to greater computing power than what's available on my laptop? So what you would do is you would set up Spark clusters on AWS. And then once you have those Spark clusters, you would be able to connect to them just like you connect to with a database, except you're connecting to Spark. You would put data in there, or data would already be stored on AWS. And then you would be able to run Spark on that data. So the big data sets would in theory be stored in the Spark or clusters. And you just use Spark and access it, running the Dplyr commands on the server. So that's how you would normally use it. You don't use Spark normally like I showed on your local computer. I mean, you can, but the advantage is when you start to have lots and lots of CPUs, and generally that's a bigger machine that's stored somewhere in the cloud that you have Spark running on. So the idea is once you learn these tools, you're able to interact with that Spark cluster and really like using the same techniques that you've learned for working with, a million row data, you can then scale it to a billion row data. And that's the advantage. Rashab asks, does learning R or big data as a whole from your course help to have a career in healthcare data science or bioinformatics? Yes. So while I teach general business in my courses, I found that they're applicable to supply chain. It's applicable to finance. It's applicable to accounting. It's applicable to manufacturing. It's applicable to healthcare. It's applicable to anything that you're analyzing information. You can apply the same skills that you learn. It's just the language and terminology may change going to healthcare, but the tools are all the same. You have to build reports or markdown. You have to do machine learning, H2O, or tidy models. You have to do time series. That's with my model time package. You have to do, just data wrangling, Dplyr, ggplot2 for visualization. The skills that I'm teaching you, they're transferable. So once you learn them, then you have the skills to conquer any field. Doesn't really matter which field. You have the right skill set to be able to apply and be immediately effective. So that's the goal. You want to become effective as quickly as possible so you can start adding value, business insights, solving big problems, the $1 million problems, and then automating with shiny apps. You learn that in my program. Doesn't matter if you go to healthcare or if you go to supply chain, you're going to use the same skills. It's just going to be, different terminologies. So good question there, Rashab. James asks, sounds like my question has mostly been answered. Excellent. That's great, James. I'm glad. Just let me know if you have any other questions and we'll get them answered. Anonymous asks, does LL Pro include your Slack community access, or is it only available for the full course? So I actually have two different Slack channels. There is the BSU community, and that's the main one where I'm in there, constantly. LL Pro also has its own Slack channel, but that's a different program at a lower tier. And it's something that I'm in there, but it's mainly for getting feedback on, hey, what topics do you want me to cover next, and that sort of thing. It's not really, I'm not in there troubleshooting all of the different, like, I ran into an error today. I'm, what am I going to do? Like that's for the BSU community. So that's kind of the differentiator there. All right. So if you have any other questions, we still have 4 more minutes. If not, I wish you guys all luck. I hope to see at least a few of you in the 5-course R track. I put the link there. Also, there's a Learning Lab Pro if you guys want to check that one out. And if you guys have any questions, please let me know. We'll get the questions answered. I hope that some of you can start using the skills that you learned today immediately with Spark. I think it's a fascinating technology, and it's got a lot of benefit, especially if you're working with bigger data sets. And if you want to learn the skills that you learned today, check out the 5-course R track. Check out Learning Labs Pro. And I will see you guys next time.